first day of the 30-day challenge that I'm doing to learn data structures and algorithms, and also I will be solving the lead code problem. Today I'm going to talk about binary tree. So a binary tree is a tree data structure in which every node can have at most two children. So a node in a binary tree can have no children, or a node can have one child, or it can have two children. To understand the concept of heaps, we need to understand the concept of array representation of binary trees, means how we can represent binary tree in the form of an array. So we follow these formulas to fill the array. How we fill the array is, if a node, let's take this node, if this node's index is 0, then its left child will be at index 2i plus 1, that is at index 1, or and its right child will be at index 2i plus 2, that is at index 2, and its parent will be at index lower of index by 2. So if you don't want to compute these formulas every time to fill the array, then you can fill them level by level in the array that will automatically follow this formula. But if you are filling them level by level, then you need to keep some things in mind. That is, suppose we have a binary tree of this form. This tree does not have two children. So if you don't leave space for these children, then these formulas will not be followed. So to follow the formulas, fill the array level by level, like 1, 2, 3, then comes 4, 5, then this 3 does not have two left and right child, so leave two blank spaces. Then this 4 does not have left and right child, leave two blank spaces. This 5 has 6 and 7, fill them. Now this array will follow these formulas that will only represent the binary tree. Otherwise, if you don't leave the spaces, the binary tree criteria will not be fulfilled. To understand the concept of heap and complete binary tree. So there are some types of binary trees, but I'm going to be only talking about full binary tree and complete binary trees. So a full binary tree is a type of binary tree in which every parent node or any internal node can have no child or one child or two children, sorry. Any node cannot have only one child. That will not make a binary tree a complete, a full binary tree. So as you see, this binary tree is also a full binary tree because every node has either two children or no children. There is no node with only one child. So that makes this tree also a full binary tree. This is also an example of a full binary tree. So now let's talk about complete binary tree. Complete binary tree is like a full binary tree, but there are some differences. The differences are that every level must be completely filled. What that means is we must fill the levels from left to right. So then only it's a complete binary tree. So while filling the levels from left to right, completely filled levels means the levels in which there are no missing left child, but there are right child. If there is a right child, then it should have a then there should be left child also. That is a completely filled binary tree. And what makes a complete binary tree different from a full binary tree is all leaf elements must lean towards the left. Means, as in this tree is not left leaned as its leaf elements are not leaning towards left. There is a gap here, but this is a complete binary tree as its all leaf elements are left aligned. In this also all leaf elements are left aligned. And the last leaf element might not have a right sibling. What that means is this is a last left leaf. So this leaf, last left leaf, can have a right side or it cannot have a right side. Either way, this will still be a complete binary tree. So that's it for today.